Now, we typically won't see mid-column oversize in the muck pile. At the top of the muck pile, like we do cap rock. See, everybody sees the material that's part of the stemming. We all can identify that material, the large oversize sitting on top of the muck pile after the blast. It's a little bit harder to see if there's oversize in the actual shot or in the bottom of the shot. And really, the only way we'll know this is if the loader operator notifies us that there's a problem. It gives us a lot of information to understand where some problems are occurring, not just with oversize, but maybe with not properly pulling to grade, maybe with some other problems, let's say on the heave end, we're not getting good enough heave or scatter of that muck pile, so the operator is having a much more difficult time digging. There's a lot of reasons that can occur, but at minimum, we want to know that it is occurring. Now, we can also do multiple drone flights, and this would be something I'd recommend for everybody when we're looking at doing a fragmentation analysis. We don't just want to do one flight right in the beginning, and this is one of the major benefits of having drones. I remember back when we used to have to take the cameras and take pictures, and we'd stop production. We'd lay out different scaling metrics. We'd take a bunch of pictures of it. We'd go back, and then 3 hours later, we'd come back into the site, put it down a bunch of markers again, take a bunch of pictures, leave again, and do that on and off all day. The problem with that is it leads to major downtime losses on all of the equipment there. It significantly slows down the overall load muck haul process. And today with the drone flights, we don't necessarily have to do that. We can fly a drone every 30 minutes if we wanted to and never have to shut production down. And what we can do then is we can get the 3D fragmentation analysis using a software like Straos from multiple different parts as we go through the entire process. And when we do that, we can actually go about pulling together all of that information from multiple different points in time. We can put in all the new surfaces and then compile that into one fragmentation curve for the blast that really lets us see how the entire blast has trended.